Okay, here we go. This is me going through the problems that we went through in class. Um, so let me read it again. A skateboarder starts from rest, maintains a constant forward acceleration of 0.5 meters a second squared for 8 and 4/10 seconds. What's the rider's displacement during this time? So we're looking for some sort of distance. So I'm going to use number 2 over there because I have acceleration. I'm looking for distance or displacement. That's what I don't know. This is A. And, oh, I lied to you. And I have time. So I guess I have to use 1/2 AT squared. Sorry about that. All right, I have acceleration. I'm looking for distance, and I start from rest. And so all I have to do is use this formula. The final displacement, that's what I'm looking for, is equal to the initial displacement. Well, it starts from rest, so there's no initial displacement, plus initial velocity times time. Well, it starts from rest, which is our initial velocity, so that goes away as well. So all I have to do is the 1/2 times the acceleration, which is 5/10 meters a second squared times the time squared. Okay, and you'll see what happens. I'm going to grab a calculator, which is right here. You're going to see what happens when I square this. So I'm going to do it really, really, really slow. 8 and 4/10 squared gives me 70 and 56 100ths seconds squared times 1/2 times another 1/2. But this is meters a second squared. And this second squared gets canceled with this second squared, and then multiply that by 1/2 as well. So 0.5 times 0.5 times 70.56 gives me a grand total of 17 and 64 100ths meters, and we can round this to about 17 and 6/10 meters. I'll have you round everything to 1 decimal place. All right, so that's the first one. I'll set this down. We'll scroll a little bit to the next one if I can, because I don't know where I am. There it is, the sports car. Let me get rid of this. A sports car. Sports car moves 100 meters in the first 4.5 seconds of constant acceleration. So we're assuming he's starting from rest, and we're looking for acceleration again. So we could rewrite that x final equals 1/2 AT squared, right? Because we're given time and we're given distance and we're looking for acceleration. Well, we're given the final distance, we're given the time, we're looking for acceleration. So that's the only thing that's missing there. All right, there's no initial distance, there's no initial velocity because we're starting from rest. So we're just going to rewrite this. So it ends up being 2 times the distance divided by the time squared gives me my acceleration. Okay, and that's just me rewriting this for acceleration, right? And we have all this stuff. So here we go, 2 times 100 meters. And then what's my time? My time is 4.5 seconds. Don't forget, we have to square this, and that's going to give us our acceleration. So again, I have to get out my calculator and put it in. We know that that's 200 divided by 4.5 squared, and we get an acceleration of approximately, right? Approximately 9 9/10. Give it the approximate meters a second squared. Good? And there it is. So we're going to move on. I just want you to remember this is meters, seconds, but because we squared it, meters a second squared. So that's our perfect unit. Moving on to the next problem. So far, we've only used 1/2 AT squared or some version thereof. And let's see if I can get this to move a little bit. There we go. Here's the ball. The ball has a constant acceleration, so we've been given acceleration of 0.33 meters a second in the same direction as its movement. What is its speed? What is the velocity? I'm looking for velocity final after 3.6 seconds. So we have to find out what a final velocity is if we're only given acceleration and time, right? We're not given any distance. We're not given any, we're given an initial velocity, VI, up here, 1.6 meters a second. Sorry, I forgot to read that. So here we go. We're going to use the first one. We're looking for VF. You've been given VI, you've been given A, we've been given T. So VF equals VI plus A times T. So let's write it out. VF is equal to 1.6 meters a second plus the acceleration of 0.33 meters a second squared times the time, which is 3 6/10 seconds. And then I get my handy dandy calculator to do all this work for me. And we put in 1.6 plus 0.33 times 3.6, and we end up with 2.78. So 2.78 meters a second, because this seconds cancels out with one of those. But I'm going to rewrite it as about 2.8 meters a second. Sorry about that. Wow, that was large. There we go. And then how far did that thing travel? There are two ways to do it. I'm going to use the second formula because we haven't used it yet and we have all of this information. Why not? We could, right? Because we have initial velocity and acceleration and time. We could use the last one, right? But we also have a final velocity now. So I'm going to go ahead and use that final velocity number and rewrite the second formula, VF squared minus VI squared divided by 2 times the acceleration equals that distance. How far did it travel? So I'm going to go ahead and use this. You could use the other formula if you want. All right, so what do we have? We have a final velocity of 2 at 8/10 meters a second. We're going to square it. Then we're going to subtract from that our 1 and 6/10 meters a second. And square that, find the difference there, and then 2 times 33/100 meters a second squared, and we're going to end up with some sort of value in meters because we're looking for distance. Okay, so we get out our handy dandy calculator one more time, and I'll put it in. Divided by, and we come up with 8 meters, right? We come up with something pretty close to 8 meters, maybe just a tad less than 8 meters when you use that formula over there. We should be good. All right, so that's that. We have another page. Oh no, not another page. So this is a long video. You'll have to live with it. Here we go. There it is, the toy rocket. There it is. Oh, that's it. That's all I got. Oh, there it is. 2 more pages. A toy rocket is shot straight up into the air with an initial speed of 45 meters a second. How long does it take for the rocket to reach its highest point? So we're gonna use a formula to find time, but we're only given initial and final velocity, and we know the acceleration, right? So the initial velocity is 45 meters a second, we said. When it gets to the top of its flight, its final velocity is 0 meters a second. The acceleration for this is -9 and 8/10 meters a second squared, because we're talking about gravity pulling on it as it goes up. And what are we looking for? We're looking for time. So what formula do we usually use? We're going to rewrite that formula over there. So T equals VF minus VI divided by the acceleration. Okay, so let's write it out. 0 meters a second minus 45 meters a second divided by the acceleration due to gravity, which is -9.8 meters a second squared. And if you look at the units, they cancel out beautifully, and we only end up with seconds. All right, so if we find out what -45 divided by -9.8 is, we come up with just about 4 6/10 seconds. So the second part of this is, how high is this rocket above the ground? Now, last time I used the second formula. This time I'm going to use the third formula because I want you to see that they both work. So I'm going to do x final. There is no initial distance because it starts from the ground. We do have an initial velocity, and we do have a time now. And then we're going to do 1/2 a t squared. Okay, and I want to show you this this way because we're going to keep using gravity as a negative, and I'm going to show you that this gives us our whole distance. This cuts it in half because gravity is pulling on it until it gets to the top. So what's our initial velocity? It's 45 meters a second times 4 6/10 seconds. Then we're going to add to that 1/2 times the acceleration, which is negative 9.8 meters a second squared, times 4 6/10 seconds squared. Okay, and then if you want to do it piecemeal, you can. I usually do the whole thing, but we'll do it piece by piece. 45 times 4.6 says if there is no gravity, right? If there is no gravity, we go 207 meters in the air, right? Because the seconds cancels out with this seconds. We got 207 meters. So let's do 1/2 AT squared, 1/2 AT squared, which is negative 103.68. All right, and if we put these two things together, we get just about 103 meters and 32 100ths, right? So we would say it's 103.3 meters. Yay! Okay, I know this is long, keeps going. I need to get to the final page, which is just the acorn, right? So, the acorn, onto the acorn. Here we go. Sorry about that. Not doing a velocity time graph for it. Get rid of that spot. Here we go. A squirrel drops an acorn from a branch that is 8 meters from the ground. How long is the acorn in the air? And so we're going to take x final equals 1/2 AT squared, rewrite it, and I've shown you this in class. The time is equal to the square root of 2 times the distance divided by the acceleration. Well, we say x is 8 meters. We say the acceleration is 9.8 meters second squared. And you asked me, hey, Mr. Sokol, didn't you tell us just a second ago that acceleration was negative because it's going toward the ground, going toward the center of the earth? And I say, yes, but this acorn is only moving in one direction, and we're just going to call downward positive for this problem. If you make it negative, both things are going to be negative, and you divide a negative by a negative, and you get a positive. So let's just go ahead and write it like this. This is going to be equal to 2 times 8 meters divided by 9.8 meters a second squared. And we're going to take the square root of that, which is the same as 16, square root of 16 meters divided by 9.8 meters a second squared. And it's just something a little bit more than 1, obviously. But let me go ahead and do it. The square root of gives me just about 1.3 seconds. 1.277, so I'm going to round it to 1.3 seconds. And then what's the speed just before it hits the ground? Well, we're going to go back to that first formula and solve for final velocity. So VF equals VI plus AT. Well, there's no VI in this situation because it starts from rest and then just begins to fall. So what's our gravity? Again, unidirectional. So we're going to say that the time we found was 1.3 seconds, and the acceleration is equal to 9.8 meters a second squared. So we're just going to multiply those two things. That gives us 1.3 seconds times 9.8 meters a second squared. I apologize, I put time first. I know it says AT, but the commutative property of multiplication says I can multiply in any order and still come up with the same product. So what is 1 3/10 multiplied by 9 8/10? We get 12 74/100. You saw that this seconds cancels out with one of those, so we are in the correct unit, meters a second, but I'm going to say round it to 1, and there you have it. Wow, long video. I'll get out of the way. So if you need to take a picture of this or you need to see a picture of this, now you have it.